Yo, hi guys. This time I'm going to make a simple program that will show snowfall in command prompt. By achieving this program, like dropping the snows in command prompt, I will need to use threading, which is something like a multiprocessing. So in threading, I will have to branch out into two threads. One is to get the user input, another one is to get the UI printing stuff and updating. So I will use a timer to record how long do I need to finish up this program. I hope that this can help you, like maybe in your assignment you want to do something like a real-time displaying while accepting the user input. Yeah, maybe it can help you at some point. But this time I'm not going to touch any deep things. I'm just going to use the simplest way that I can think of. Well, without further ado, let's get started. Wait okay. Yeah. Main class, as usual, with the main method. String argument s, and in this point of time, I'm going to use buffer reader. Which is similar to the scanner, but it is like a more faster one and a more limited one. But I'm sure that this is enough for me to achieve the standard input which I want, right? So, well, through br.readline, which is the snow position, I'm going to allow the user to get the snow position, like which place they want the snow to fall, and I'm going to pass the string to integer, because the buffer reader can only get the integer, the string input. Okay, if it is -1, I need to break the program, else I need to do something. Yeah, so in order to hold the position of the snow, I need another class which is called the position, with private integer x as well as y. So this integer x and y will indicate the position of particular snow object, and it will be like having a constructor with this dot x, with setting the value for x and y, and we'll need a setter and getter for x and y as well. So this is called encapsulation, which we will not directly let the user to edit anything they want. So this is a setter, and I'll get a getter as well. Wow, voice sucks. Okay. Return x, and same thing will apply to the y as well. So this is the integer y, this of y equals to y, and a return of y. So now we have done with the object for the class for position, which have the getter and setter for x and y position. And here we'll have a position controller, which will be the bridge between you and I, between the main method and the UI thread, main thread and the UI thread. So you'll start with the snow position x, and the position for y is 0. So now we will have to implement the UI thread now. So I will call it as a snowfall, which implements runnable. So runnable is the interface that you should implement if you want to use the threading. So in this case, it will have to override one thing, that is the public void run. This is mandatory for a runnable to have. It's a main method for the thread. So I will need also a volatile boolean, which is something like a flag, to indicate whether I should close the flag or not, the thread or not. Okay. So inside the constructor here also, I will accept one thing, which is the position controller, and this dot position controller equals to position controller, and I need to to hold the value of position controller as well. And also we need an array list of position which indicates the position of each and every snow. I will initialize it here. Save time. Okay. Alright, now this run is a main method, right? As I mentioned, I will use the is running as the indicator whether we should continue or not. Then it will do the main stuff here. And also I need to expose a function which is the shutdown that enables the main thread to actually close the flag to false. Alright, that's it. This one is the main method. Then we need to initialize the snowfall here to be used in the main thread. Equals to new snowfall. Putting in the I see here. Here I cannot put the initialization every time here. In fact, I need to put here and controller. Put the position controller inside and add a new thread. With constructor is the parameter for constructor is the snowfall, which is a lowercase one, and I will start the thread like manually. And then here I need to snowfall.shutdown. I need to shut down the program. Okay. Then here, if I don't shut down it, I need to modify the position controllers by x value equals to the snow position. Alright. Every time I get the input, I need to update it. If it is not -1, if -1, I will exit the entire program. And now it's time for us to implement the main method for our UI thread. So how can we implement it? First of all, we need to try and catch. Why we need to do that? Try and catch, I need to not handle each and every exception. So here I will have a magic function which I found online that enables me to do something like okay, do something like a clear screen for Windows. It will only work in Windows, by the way. So I don't want to run the thread like every single second, so I need to call them to wait like every 1 second. Yeah, you run it. I don't want it to run like every time, keep looping infinitely. I want it to wait 1 second. So now I need to add the snows, which is the new position. With the x position is a position controller dot get x, and the y position is 0, and snows dot for integer I equals to, no, I need to get the snow number, which is the snows dot size. So starting from the latest one, which is the -1, and I greater than equal to 0, I minus. I start from the latest one because of the printing purpose. So I need to do an indication to check if snows dot get I dot get y. If the y position is is greater than 15, I will do something like this: snows dot remove I. Why? Because if the value exceeds the I'll give a range for the y-axis, else it will like keep looping infinitely, keep going down infinitely without the border. So I'll do a continue like to ensure that I will not run the things below. And here I will set the y position, which is the snows dot get I dot set get y plus 1. So printing time j equals to 0, j less than snows dot get I dot get x, J++. This time I will print all the print. I'll print all the spaces we have based on the number of X value. And lastly, we'll print the empty. Oh, we print the snow. Right. Print the start. Try cache. Are we done? Are we done yet? There's a bunch of error because I didn't import anything. Now, one error. Position controller, new snow position. What the hell happening with the snow position? Variable snow position. Hey, this is 0, man. You start from 0. Then we test. Faster, bro. Okay. This is my bad. I didn't throw any exception, so I don't want to handle any exception. Yeah, don't force me to. Hey. Okay, Java main. Print 4. Okay, now print 10. Looks good. 40. Okay, so as you can see, when the snow is falling down, it will hit a certain point where the snow will be destroyed. So it will not like exceed the limit and going down forever. It will stop at some point. So if I know 5, yeah, you'll get a 5 here. And if I press -1, it will end the program. So that is it. So this is the program for, oh no man, I need to close it. Okay, so this is the program for snowfall. I'll briefly explain what I have done, and I hope that it will not have any edge cases which I didn't handle, because I tried my best already. So in the main method, we'll have a buffer reader which in charge of a standard I/O, and a position controller which is the bridge, the connector between the main thread and the UI thread. And we will have the UI thread which is snowfall. You see the parameter is a controller, and we start a new thread. On the other hand, every time we get a user input, we will check if it is -1, then we break the whole thing. We break the main thread, we break the UI thread. Else, we will set the position of the position controller so that the change will incur in the UI thread. So this is the UI thread we have, which implements runnable. Then this is the main method for the thread. Well, we'll see this is running is a flag, which indicate whether we should close the program or we don't. And position controller as usual, this is the connector with the main thread. We have a bunch of snows. Well, while it is running, I will clear the screen, then I will add a new snow. After I add a new snow, I will check if the snow exceeds the limit of 15. If it exceeds the Y, then I should destroy the snows. Else I will update the Y value, as well as printing according to the number of X. This is to print the spaces by the number of X user input. Okay, this is to print the snow. Then every time I need to sleep for 1 second, else it will be updating like really fast that you cannot catch at all. So sleeping is good for a smoother experience for UI. Okay, so what I said just now, never mind. So that's it. This is the implementation for snow falling. This is a useless project, but threading itself is useful. I hope that you can learn something. Like, as you can see here, it's pretty much similar to Tetris, right? Going down. It's not the Tetris in your assignment, but the Tetris in the actual Tetris game. So actually with threading you can play a lot of different stuff. I hope that this can help you to get a insight of how to code like for something. Yeah, how to code for something to achieve something. So this is a really simple example. I hope that you can gain something out of it. If you are not familiar with threading, I really suggest you to keep an eye on it because it is really important. You don't want to keep waiting for the user input for your future programs, right? You want it to be responsive. So yeah. What else? Well, I think that's it for this video. Oh yeah, I will put the project in GitLab and put it under description. I hope that if you want to check, you can check it out. Yeah, feel free to check it out. That's it. See ya. Bye.